Good morning, students. Today I am going to teach the lesson Matter in our surrounding. Introduction. See here a pencil, a pen, a table, the food we eat, the clothes we wear, the walls of our houses. Everything is made up of matter. But I am asking you all, what is it to be matter? See, matter is any object, it occupies space and it has mass and can be perceived out by our eyes, then that is said to be matter. So, matter is used to cover all the substances and the materials from which the universe is made. This is said to be matter. Next one, matter is made up of particles. Matter is made up of particles. How it is? See here, in this experiment, see here it is written over there, that is the given example is water. Okay, this water is made up of particles. See here, you can see this in this beaker. Here we are having the water molecules are present over there. The inside that, see here, these molecules, we are having the molecules present over there. Between that we are having the spaces are there. These spaces is said to be intermolecular spaces. See, because of that reason, when we are adding salt over there, it mixes with this and we are getting the solution. This is not happen in solid and all. When we are putting solid directly to the beaker without water, it is as it is only. Why? Because these molecules doesn't have a space in it, but the water molecules have the space. Because of that, it catches the salt and we are getting the solution. See here how small this is. This all the matters are made up of particles, that we know that. Now how small it is. These particles are how small. See here, this experiment proves that I am taking 100 ml of water here. Now I am taking only 2 potassium permanganate crystal. Okay, only 2 piece, small piece it is. Now when I am adding over here, this color, the water gets colored because this water potassium permanganate crystal mixes over there and we are getting the solution. That is, what is that? A colored solution we are getting. Now from this I am taking 10 ml of this solution. From this I am adding over here 90 ml of water. So we are getting the total amount is 100 ml. Here also you can see that this is colored one. So again I am taking the same method. I am doing till more than 7 to 8 experiment. So till the water become clear water. So I am doing like this. So what is that? All the beakers showing that. See, compare here. This is little darker. This is little less. Like that it goes on. But all the water is said to be, what is that? Colored one. So it proves that these particles are very, 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 very small. It indicates. So all the matter is made up of particles. The particles are very, very small in size. So here, this is proven by one of the theory, that is said to be the kinetic theory of matter. What theory says? See here, all matter comprises of small particles. These particles have space in between them. These particles are continuously moving. These particles attract each other. Next one, matter has 3 states. In general, we call it as, we studied from our earlier classes, that is, it has all the things that is have 3 states. Actually, these matter has defined by 2 ways. One is by physical method, second by chemical method. Here we are studying only about the physical method. In this method, the matter has 3 states. Actually, now scientists has discovered that 5 states are. What are the 5 states are there? Number 1 is solid, number 2 is liquid, number 3 is gas, number 4 is plasma, number 5 is Bose-Einstein condensate. Now we are going to concentrate more on solid, liquid and gas only. See here, this is the states of matter. The solid, the best examples are stone, wood, diamond is given over here. Next one, liquid, all the water, what is that, juice, this and all, oil, these are coming under liquid category. Third one is gas. Gas is the best example is cloud. Next one, see here how the matter is present over there. States of matter, solid. The best example is ice. This is the simple one. Ice, when we are melting over, heating over there, we are getting liquid. That means water we are getting. Then go on heating, it changes into gas. That means vapor we are getting. This is the states of matter. Solids have a definite shape and volume. They are harder than liquid and gases. Liquids have a definite volume but no definite shape. They take the shape of the container in which they are kept. For example, I am giving you in the liquid. So suppose I am buying 1 liter of juice from DMart. Now what I am doing, when I am coming to home, I am transferred into glasses. So here what happened, the volume is same only. 1000 ml I bought, the same 1000 ml, that is 1 liter I have. But only the shape is changed. Now it takes the shape of glasses. So this is said to be the definite volume. Okay, but it doesn't have a definite shape. Understood this? Next we are going to gases. Gases have no definite shape or volume. Shape also no, volume also is not there. They occupy the entire space available to them and take the shape of the container in which they are stored. For example, I am taking one perfume bottle. Then just I pressed over there. The whole room gets the fragrance of this. How we are getting it? Because it has the molecules, it mixes with the air around the room and it takes the whole room, it takes the volume. So it doesn't, that is why we call it as it doesn't have any shape or volume. Next one, particles of matter have space between them. So I already told you that is in the water molecule. We are having, I showed that the water, it has the intermolecular space. All this, see, matter is made up of small particles. These particles have small spaces between them. These spaces are invisible to the naked eye. But particles of other matter can get between these spaces without increasing in volume. So this is, what is that? Particles of matter have the properties. Next one, rigid and fluid. What is it to be rigid? The solid one, for example stone, is rigid because it is unbending or inflexible. Whereas the solid is a rigid form of matter. Because of this rigidity, solid have a tendency to maintain their shape. It has a particular shape when subjected to outside force. Okay. Next one, it doesn't need any container to keep them. The best examples are brick or wood or many things we can see that. Again, fluid. What is it to be fluid? A material which can flow easily. We call it as fluid. See, fluid, what are the examples for this? A liquid and gases are the best example. But these two have difference. Liquid and gases, what is the difference between them? A liquid is a fluid form matter, but it occupies only the lower part of the container. Okay, see here, what it has actually, it has a well defined surface so that we can keep it in a open container. Whereas gas is, what is that? This is also fluid, coming under the fluid category, but we can't store in a open container. Why it is like this? Because it doesn't have a free surface in it. So because of that reason, we are, what is that? We are having the best example is LPG cylinder or CNG cylinder. What is it to be LPG? Liquid petroleum gas. Liquefied petroleum gas. CNG, compressed natural gas. In this case, what is that? Here the air is compressed and kept it in a container, that is the cylinder. Okay, so this is the difference between liquid and gases. Next one, difference between liquid, gas and solid. See, solid have a fixed shape and definite volume. Liquids have, this also have the fixed volume. Next one, gases have no fixed volume and shape. Here, solid shows only slight expansion on heating because these molecules are tightly packed with each other and doesn't have any intermolecular space in solid. That is why the outside force does not act on it. That is why it has a fixed shape. Now, liquids, this shows a slight expansion on heating, but more than solids, less than gas. Gas is what is that? It expands considerably on heating. Next one, intermolecular forces. That is forces. We are having we studied about the intermolecular spaces. Because of that, here the molecules have the capacity to attract with each other. Because of that, it produces the forces. That force is said to be intermolecular forces. These intermolecular forces are very strong in solid. That is why they are closely packed. Whereas in liquid, the intermolecular forces are strong enough but comparatively less than that of solid. That is why the particles are not strong as compared to that of solid. Next one, gases. Here also, compared to these two, this is less. The intermolecular forces are less compared to solid and liquid. Next one, compressibility. Compressibility is 0 in case of solid. Whereas liquid, little, it has compared to solid is little more than that. Whereas gas has high compressibility. Next one. See, compressibility means what? See here, in gas, what is that? The molecules are present in, what is that? See here, in gas, the molecules have more space in between them. Because of that reason, when we are pressing over there, it can compress. When we are pressing that, what happens? We can put more molecules in a container. Because of that reason, when we are compressing the molecules, it has space in it. Because of that reason, the more molecules can occupy the container and it changes into liquid. This happens in LPG cylinder and CNG cylinder. Okay. Next one, solids do not flow, whereas liquids can flow, whereas gas flows freely. This is the difference between solid, liquid and gases. Next one, interconversion of the state of matter. What is that? See here, the solid is there. See here, there is no intermoleculars. These are all molecules. Okay, these molecules doesn't have space in between them. Okay, these molecules are closely packed with each other because it attracts the forces, intermolecular forces more. That is why these are present like this. It has a definite shape. Whereas when we are coming to this in the beaker, these are all the molecules are present here. This is little, it has the intermolecular space is present over here. Whereas in gases, these molecules have more space in between them. That is why the intermolecular forces also less over here. Here more, here compared to this is little more or less, but this one is very less here. Intermolecular space is very force and is very less. Now, I am going to say this. When we are breaking this molecule, how do we break this? When we are heating over there, what is that? That process is said to be melting. These bonds gets break down and we are changing into liquid. When we are melting, that means when we are heating the solid substance, it changes into liquid. Again we are heating this, it gets evaporate. That means vaporize हो जाएगा. Then that is said to be gas. This is called evaporation. Next one, we are reverse process. When we are cooling this is said to be condensation process. It changes into liquid. Again we are cooling. That means we are keeping in the freezer. We are getting the solid. This is said to be interconversion of matter. Next one, see here the effect of change of temperature and pressure. This is also same like that. See here, this is the solid substance. When I am heating over there, what happened? It changes into liquid. Again we are heating. That is, the heat is absorbed over there. The energy is, we are getting it with the help of heat. It changes. Here the molecules gets break down and it changes into gas. Next one, heat released over there. How it is releasing? See here, the gas substance, when we are, that is, we are taken away the, we are getting the heat back. That means we are cooling it. What we are getting it, this is condensation process. We are getting the liquid over here. Next one, when again we are keeping in freezer, that means it changes into the liquid, changes into solid. This process is called solidification. Here, what is written over there? Sublimation. What is said to be sublimation? Sublimation is, again, this is solid substance directly changes into gaseous substance. When we are giving heat, it directly changes into gas. Then this process is called sublimation. See here, sublimation is the process, the changing of solid directly into vapor on heating, and the vapors into solid on cooling is known as sublimation. See here, the solid, when we are heating it, this is changes into vapor, but this is not changes into liquid over here. Whereas the vapor, when we are cooling it, is directly changes into solid. There is no liquid formation between this. This process is called as sublimation. Ammonium chloride, iodine, camphor, naphthalene, anthracene. Then one more example, solid carbon dioxide, that is dry oxide, dry ice. This is also the example of sublimatory substances. Next one, evaporation. Evaporation is the phenomenon in which a liquid changes into gaseous state below its boiling point. See here, I have to mention that boiling also. So what is the difference between boiling and evaporation? The evaporation takes place in all the temperature. For example, 30 degrees Celsius, 40 degrees Celsius, 50 degrees Celsius, all the Celsius the evaporation takes place. Whereas boiling is take place only at the 100 degrees Celsius. This is the first difference. Then again, the surface area. Okay, this is the main difference between evaporation and boiling. Now, what are the factors involved in evaporation? What are the factors affecting this? For the first one is temperature. Then all the temperature it take place. Then again surface area. Surface area also important. If the surface area is more, the evaporation is more. Next one, weather condition. But weather condition, you take the humidity. Here the opposite process take place. If the humidity is more, the evaporation is less here. The humidity means what? Water content in the atmosphere. If the water content in the atmosphere is more, the evaporation rate is less over here. This is said to be evaporation. Now, the evaporation, it causes the cooling effect. How it causes the cooling effect? When a liquid evaporates, it draws the energy from the liquid itself. Hence, it keeps cooling. That is why, see, I will give one more example here. What is the example? If you take the earthen part, when we are in the summer season and you keeping water over there, it becomes cool. How it become cool? Here it has microscopic pores are present on the part. These pores absorb the water and evaporates to the atmosphere. Because of that reason, what is that? It draws energy from the liquid. Because of that, this part gets cooled. Okay. Next one, latent heat. What is said to be latent heat? Latent heat is also called as hidden heat. What hidden heat? See, heat which required by substance to change its state without rise of its temperature. It is called latent heat. What is that? What it means actually? Actually, see here, uh, I will explain by this experiment. See here in this experiment, see this is the tripod stand is there. Here the gas burner is there. Here what is that? Beaker with water is there. Now the gas flame is there. Because of that reason, the water is getting heats up. See, I am measuring the temperature from the beginning only. First, it shows that 10 to 15 degrees Celsius. It goes on rising. That is up to, that is when it starts boiling, this thermometer reads the measurement, that is 100 degrees Celsius. But here, what is the condition here? The gas burner is still is burning only. But the temperature is not rising. Why it is not rising? See here, this is said to be the latent heat. Why it happens? But here that thermometer shows the reading 100 degrees Celsius only. But I am giving the energy by with the help of burner, that is heat. Heat I am giving the energy, but the temperature is, what is that? The thermometer is not showing the measurement. What is why it is? See here, what is happened here? Here the state is changed over there. Once it starts boiling, the state of the liquid is converted into gaseous state. Here where my energy is going, this energy is breaking the liquid molecule into gaseous molecule. That is, molecules breaks up. Because of that, it starts evaporating. That means it changes to gas. Because of that reason, this temperature remained constant only. Okay, it shows only 100 degrees Celsius, but the state is changing. This is said to be the latent heat proved by the experiment. See, latent heat of two types. What are they? Latent heat of fusion, latent heat of vaporization. Latent heat of fusion means what? Melting. Latent heat of melting. Next one, latent heat of vaporization. What I told you, that is said to be the latent heat of vaporization. Latent heat of fusion, here what is that? Here take this one. Take one ice cube. They see the temperature of that. It shows 0 degrees Celsius. When I am heating it, still it shows the temperature 0 degrees centigrade Celsius only. Here what happened? But the process here, the state is changing. What is that? The ice breaks and we are getting the liquid from this. So this is said to be the latent heat of fusion. I will read out this. Latent heat of vaporization, the amount of heat in joules which is required to convert unit mass or 1 kg liquid in vapors form without rise in temperature is known as latent heat of vaporization. In water, experimentally they proved that 22.5 into 10 to the power 5 joules. Okay, so this is said to be the latent heat of vaporization. This latent heat of vaporization varies from one substance to another substance. Okay, these are the things we studied here. What are the things we studied here in this chapter? We studied about the states of matter, different states of matter, and the process like melting, sublimation, and latent heat. These are the things we studied over here. Okay, thank you very much, children.